And with the applet here from Rossman and Chance, we're going to see what happened when the data, the population only has two options, yes and no. In this case, we're looking at the Gettysburg Address and whether it has the words in it has an E or does not have an E. And we see here the proportion of letters that has an E is 0.466, 46 per them. 46.6 of them have letter E. So in here, I will reset this and I can have number of samples, so I should take one sample, and the sample size is going to be very small. I'm going to do only size 5. So what happens when I do that? I get 5 dots in here, 1, 2, 3, 4, 5. This is my sample, and in here, or sample distribution, and in here I have the proportion of those, and in here the proportion happens to be 0.8. It says the word mean, don't get confused about it, it's just the sample proportion, so that one happens to be the center. It's calculating the center of this sample proportion. And the proportion we achieve from the sample is 0.8 is in here, so it's the same. So we do it again one more time. Now we have a different sample, it happens to be the same number. We do another one, now a little bit different. So this sample happens to be 0.2. And now we see here plotting into the sampling distribution. Again, these plottings are the empirical sampling distribution, meaning they're not the theory. We're just doing some replications, some of them, so to see how the behavior it is. And so we do another one. And we can do like this, and of course we can keep clicking, and we'll take us a while to do a sample size of 5. So let's do 100 then. I'll do a sample. And let's see, there it is, this is 100. Notice what happened here. This looks almost like a normal curve, but the problem is we have all these gaps in here, you know? And that's because the sample size is very small. We only have a sample size of 5. So we cannot say that the sampling distribution or proportion is normal when the sample size is very small, because all these gaps in here, if you overlay the sampling distribution on top, you see they're not even close to what it's supposed to be. So basically this is not working out for us very well. So what we're going to do now, we're going to reset this. I'm going to increase the sample size. Let's say the sample size maybe 30. Let's do a different number. Let's do 50. All right, and then we draw a sample. Now we see this is our last sample. We see all the distribution of the samples. And now we're closer, much closer than we were before. Still there is gaps in here, and this is one simulation. We can do maybe a larger sample size. I mean, number of simulations, maybe do 10,000 of them, so maybe closer to what we're looking for. So do it again. So that's a little better. Still we have this spike thing here. So the normal distribution is an approximation to the sampling distribution of proportions, because it's never going to be perfect. It's going to be close enough and not perfect. So we can reset it and do it again. And again, this is sample size of 50. So what happens if we increase the sample size even more? Let's reset, let's do 100. Again, we have this like not perfect normal distribution, but it's closer. So we're going to call the normal distribution a close approximation to use the sampling distribution of proportions. Notice here that the average of the center of the sampling distribution of proportion is 0.468, and again this is an empirical, so it's not a theoretical, but it's very close to the population here, which is 0.466. This is 0.468. And so the sampling distribution is always centered about the center of the population, in this case the proportion of the population, and the sampling distribution, which is full of proportion. So remember also, if you're clicking here, this is a different proportion. It's 0.45, and in here 0.42. Notice that the proportions are not too far off from the population proportion. They are from, you know, somewhere here 3.9 to somewhere here 5.5. So the majority are within very close to this population proportion. That's very important to us also. So I hope this understands a little bit more about how the sample distribution for proportion it has a shape almost like a normal distribution, when the population even is only binomial or has only two options, yes and no. and we're going to do this for the proportion sampling distribution. I hope this clarifies.